This was our screen from our last video. Quite crowded with X, Y's and letters and plus signs. But we're going to be using many of these things that you're seeing on the screen in this video. Now, what we did, we looked at expanding x plus y to the power of 1, then the power of 2, then the power of 3, then the power of 4. And we saw that it was a lot of work. The amount of work you had to do increased rapidly. So, for the power of 5, x plus y to the power of 5, we use the patterns that we observe from expanding x plus y to the power of 1, then 2, then 3, then 4 for the powers of x and y. And then Pascal's triangle, we use that to get the numbers that multiply the x and y. And this was Pascal's triangle. We found Pascal's triangle, where it's a triangle because of the shape of it, these numbers here. And these are the numbers that multiply the xy's. Alright? Now, we looked at x plus y to the 6 and x plus y to the 7 from following those patterns. And we said, suppose you are asked to expand without the previous expansion. So you're not seeing a pattern to follow. What would you do? For example, suppose you were asked to expand x plus y to the power of 15. Alright, let's see. I've seen this formula for the terms of a binomial expansion. It is written n CR. If it's x plus y to the power of n, if you have x plus y raised to the power of n, is equal to NCR, x to the r, y to the n minus r. So that's the formula that we have, where NCR, remember a combination, n is the number of terms that we're going to have, and r is how many we choose. And then x and y would be the x and the y you see here in bracket. Now, let us look at this formula and see how it works in the expansion x plus y to the 1, x plus y to the power of 1. Here, NCR, what that will give you, you have 1x and 1y, and the power will be 1. So you expect when you expand x plus y to the 1, you have 1x to choose. So you say 1 available C, and you choose the 1x, or the 1y and you choose the 1y. Alright? Remember, n is the power, so it will give you the powers of x eventually. So it's, if it's to the 1, n would be 1. If it's to the 2, n would be 2. If it's to the 3, n would be 3. Because this x plus y to the 3 means you have 3 brackets multiplied, so you have 3 x's. You also have 3 y's, but we concentrate on x's now. We have 3 x's. The number of x's available here is 1, and the number you choose is 1. So it's 1c1, right? Then x to the power of 1, y to the power of 0. Now, notice what happened right here. 1c1 is going to be 1. And many scientific calculators, they have the factorial notation on them, right? So you don't have to worry too much about expanding it if you have about expanding the factorial if you have a calculator like that. So The first term here is 1c1 x to the 1 y to the 0, which is this. It happened to be this. What about the second term, the one right here? In this case, what you'll have is this. Let me just erase this and rewrite it over again. Should be an x here. Now, here you have x to the 0, y to the 1. So, this part, the NCR, will give you the number that multiply the x and the y. X to the r means x to the 1, y to the 1 minus 1. So it's x to the 1, y to the 1 minus 1, which is y to the 0, which you have here. Right? And then the next term here. What this means is that you're going to have 1x and you will not, well, 0x here. With you have the x to the r. So for the second term here, for expanding the x plus y to the 1, you will have c. How many x's do you have here? In the expansion, is x to the r. It will be 0, right? You do have 1, the power is 1, but when you consider the r and the n, the r will be 0. You will have x raised to the power of r, which is 0. So you'll have x to the 0, y to the power of, oh, this is what I'm concentrating on, x to the 0. I just pointed at this, that was a mistake. It's this one I'm looking at. X to the 0, y to the 1. This shows the r is 0, and of course n remains at 1 at all times, right? What this means is that you're going to have 1c0, which is going to be, and I'm using my calculator here, I'm going to use also the expansion of the factorial by multiplying it as I go down to the next powers. But 1 factorial, this will be 1 factorial, which is 1 divided by 0 factorial, which is 1 times 0 factorial. But what that will give you is for NC0 is going to be 1. So it's 1 here, x to the 0, y to the 1. Now, it might not be clear for the x plus y to the 1, but it should be clear now for the x plus y squared. As we go down, it's going to be a bit clearer because we have some numbers to play around with. With the x plus y to the 1, it wasn't so clear. Now, you're going to expand x plus y squared. Here, let's imagine that you did not know that this number should be 2. How would you get it? You know you have x squared, x to the 1, y to the 1, x, so it's 2, 1, 0. The powers of x are 2 here, 1 here, 0 here. The power of y is 0, then 1, then 2. Right? The number that should be in front of the first one and the last one is 1. How would you get this? What this would say is NCR x to the r, y to the r minus 1. Looking at this. Minus the n minus r, I should say. N minus r. Looking at the formula here. Let me just box up the formula. Good. Now, this is saying x to the 1, y to the 1. Here, you're saying x plus y to the 2. So the power of 2. So n is 2. Whatever the power is, that's what n is. Now, n is 2, so I put this n here as 2. Now, this is saying x to the 1. How many x's you're choosing? It's 1. So r is 1. Looking at the pattern here, x to the r, this is x to the 1, so r is 1. So you change r to 1. So 1 will come here, 1 will come here, 1 will come here. So it's 1, 1, 1. 2 minus 1 is just 1. So 2 minus 1 is just 1. 2c1 is what? It's 2 factorial divided by 2 minus 1 factorial, 1 factorial. But 2 minus 1 factorial is the same as 1 factorial, so we put that there. It's 1. 2 factorial is 2. 1 factorial times 1 factorial is going to be 1. 2 factorial is 2. So 2 divided by 1 is 2. So you get this number 2. You see that? You get this number 2. Let's look at the 3 now. Power of 3. Let's erase these things. We want to make space up here. Right? Good. Let me put back this part of the line that I erased. Alright. Now, you want x cubed, no, x plus y to the power of 3. By the way, what we'll do, we'll continue the expansion in another video. I don't want the video to get too long and drawn out. So, we'll break it here and look at the other expansion using the formula in another video. So I'll see you then.